philosophy problem. So, just 5 philosophers, they are sitting here. Okay. There is a food on the table, fruits on the table, and there are the forks. 5 forks. It is shared between 1, 1, 1, 1. It is the middle. Okay. One is on the right, other is on the left side. Okay. So now we will start it. Just watch it. You will get to know what we are going to say. You will get to know. Okay, we will start.
Philosophers are here. Five. What is the shared resource among them? Four. So they need both the forks for their left hand and also for their right hand. Only then they will be able to do their job. What is their job? Eating. Instead of in addition to eating, what are the other things that they will be doing here? Thinking. So it is actually either they may think or they will eat. But when they will get that feeling of eating? When they are hungry. So these are the 3 states that they will undergo. What is that?
Hungry,
Thinking, hungry, and eating. So initially what they have demonstrated in the first round, individually, everyone were able to do it very peacefully. So one did and then no issues. The other did, the next one did, no issues. That's what they did in the first round. And in second round, what happened?
Two ate at the same time.
Two process. The philosophers are the processes here. So two try to access the resources at the same time. When this philosopher and this philosopher tried it, it worked. Because they don't have any shared resource. They are not sharing their force. Right? The idea is very simple. What is happening here? Only the neighbors are sharing their force. That's what happened as a problem in the third round. Yes or no? When these two philosophers try to access the shared resource at the same time. That's what we are telling from the beginning for the last 3-4 classes. When more than one process try to access a shared resource, it may lead to what? Data inconsistency. We call that as race condition problem. For that, we have to bring in synchronization among the problems. So, to solve this problem, now the tool that we are going to use is sum. Weight and signal. Just we are going to use the same function, but semaphore is actually an integer variable. How many semaphores we are using here? It is the chopstick that is going to be, that is the, or the fork here, we are considering as the shared resource. How many such resources are here? 5. So we are doing it in the form of an array. That's what chopstick of 5. Totally it is going to be 5. And see here, first every process will execute the weight operation. So consider this philosopher process is executing the weight operation. So weight we know, right? What if it is less than 0? No operation. If not, it will do what? Decrement the value means what? It is using the available resource. And that's what is happening. Weight of chopstick of y. So weight of chopstick of I. Okay, for 1 it is fine. Why should I do that weight of chopstick of I plus 1 again? If I consider this chopstick or fork as the ith one, means it's not the only resource that I want. I need 2 chopsticks to finish my job of eating. So for that, if this is I, means the next one is I plus 1, because we are using the sum of the form of array. Yes or no? So I have to execute the weight function 2 times. One for the chopstick on my left and one for the chopstick on my right. That is why the weight operation has been called 2 times with the parameter as chopstick of I on the first time and chopstick of I plus 1 for the next time. So why we are including this I plus 1 modulo 5 here? I can simply do I plus 1. We have a total of 5 and it is an array, and all the philosophers are going to use this 1 by 1. So at any point of time I should not go beyond 5. So whenever I reach 5 modulo 5 will be 0, again it will be the first one. Right? So for that we are including the modulo operation. Okay. So after the execution of weight, it indicates what? The shared resource is allocated to me, which means I will be able to do my job. What is my job? So my job is actually teaching. So here, as the philosopher, what is my job? Eating. So he is eating. Okay. After my job is completed, what am I supposed to do?
Leave the chopstick.
Release the chopsticks. In semaphore, we all know that using which function we can do it? Signal. So that is why we are calling signal. Signal of chopstick of I. Release the first one. And then signal chopstick of I plus 1. Release the second one. That way I am incrementing the count of the available shared resource. Every signal operation will do this, right? S plus plus. Yes or no? Which means the available shared resource will be increased. Automatically I am signaling all the other processes that there is a shared resource available, so that the next process can utilize the resource. Multiple processes trying to access the shared resource at the same time. Now the problem is solved with the help of just 2 operations, write and signal, and we call that tool as what?